Assalamualaikum and salam sejahtera. I'm Razimah binti Abdul Rahim from Polytechnic Port Eastern. Will present my paper with a title of Development and Evaluation of PV Solar Trainer with Integrated Cooling System for Enhanced Practical Training. For introduction, solar energy has become the perfect alternative to reduce a cost. This paper aims to develop and evaluate a PV solar trainer integrated with a cooling system. The PV solar trainer with a cooling system represents a noteworthy advancement in solar energy system, addressing a critical issue in region of the high temperature. This system employs a cooling mechanism utilizing fans and water pump to counteract the efficiency reduction experienced by solar panel in hot climate. For the problem statement, we developed this trainer. Why we developed this trainer? First, Polytechnic Frederickson have a 2 diploma program which related to green. One is Diploma in Electrical Engineering Green Energy and the other one is Diploma in Electrical Engineering Energy Efficiency. Both programs have learning related to PV solar and they are also students did their final year project using PV solar. So that we felt lack of comprehensive learning experience for the student and trainee in exploring PV solar with a cooling system. Second, the challenge lies in the impact of the climates and weather condition on the performance and efficiency of the system. Third, need for an innovative approach to environmental and sustainability education by developing a PV solar panel with a cooling system. And the last, to ensure a holistic understanding of solar technology and its application while navigating the complexity of the temperature regulation. The objective of the project are to build a PV solar trainer with a cooling system that can effectively demonstrate the principle of solar energy generation. Second, to develop coding of power PV solar operation of cooling system. And third, to analyze the performance of PV solar trainer and cooling system. For the methodology, first we describe about the construction of the PV solar trainer. The construction of the PV solar trainer involves integrating various components to establish a comprehensive solar and cooling system. Key components include solar panels, battery, solar charger, controller, inverter, wattmeter, fan, water pump, speed controller, Arduino, and temperature sensor. The PV solar trainer with cooling system has 100 times 90 times 90 centimeter dimension, featuring polysolar cell in a 164 times 99.2 times 4 centimeter solar panel. This is the block diagram of the PV solar trainer with a cooling system. There are 3 main blocks which are PV solar, solar charger controller and battery. There are 4 sub blocks from the battery are connected, which are Arduino, water pump, fan and inverter. The inverters are features further segmented with an initial 2 providing power to socket plugs, while the subsequent pair is designated for USB port to facilitate the connection of electrical appliances. This is the flow chart of the project, encompassing both hardware and software aspects. This project is divided into 2 interrelated segments, starting with the hardware interface creation and software development and integration using Arduino. The project is divided. The hardware phase involves a frame construction, trainer board, component, wiring, solar panel installation, and continuity test. The software phase focuses on Arduino based code creation, automated cooling system control, incorporating temperature and humidity monitoring with the temperature sensor. For the hardware development, first frame construction. The first step involves the construction of the iron frame to support the solar panel. Second, trainer board creation. The project includes the development of dedicated trainer board to house various components. Third, component installation. Key components such as a watt meter, solar charger controller, battery, fan, and water pump are installed on the trainer board. Project-based integration components are installed onto the project base, ensuring a robust and organized setup. Fifth, wiring. The wiring of all components are carefully executed, creating a functional connection between the different parts. Six, solar panel installation. The panels are affixed to the constructed frame. And lastly, continuity test. Continuity test is conducted to ensure the seamless function of the entire solar system. For the software development, first Arduino coding creation. The software development phase begins with the creating code using Arduino control the PV solar cooling system. Second, code integration. The development code is integrated into the Arduino platform. Third, upload the Arduino. The final code is uploaded to the Arduino platform to govern the fan and the water pump function through the two-way relay. And lastly, sensor integration. The DHT11 sensor is integrated with the Arduino platform to monitor temperature and humidity level on the solar panel. Solar panel specification types is polycrystalline. Maximum power output is 270 watt. Maximum power voltage 31.8 volt. Maximum power current 8.5 ampere. Weight 20 kg. Dimension is 164 times 99.2 times 4 centimeter. This is a schematic diagram. The operational logic of the software circuit is initiated when the DH11 sensor registers a high temperature of 41 degrees Celsius. The information will show on the LCD and the solar panel moisture level. Subsequently, the circuit will activate the fan and water pump connected to the two-way relay for 30 seconds before ceasing the operation. The system remains dominant until the DH11 detects another instance of the 41 degree darjah Celsius temperature. So this is the result. The graph shows the time versus current, voltage and power. The measurement is recorded in the 10 minutes for 1 hour. The highest power value was 136.96 watt, while the voltage value was 22.46 volt, and the current value was 6.06 ampere. At that time, solar panel provided a full lighting from the sun because there were no clouds. At the 6 minutes, the results show decrease in the power of 34.62 watts, where the voltage was 20.98 volt and the ampere was 1.65 ampere. At this time, the sunlight was covered by clouds. The result analysis of the correlation between time, temperature, and humidity with the cooling system are conducted over 1 hour in the evening. Data is logged every 10 minutes given the placement of two DHT11 sensors on the front and back of the solar panel. There are dual readings for each temperature and humidity data. The highest temperature is recorded is 36 degrees Celsius for temperature 1 and 37 degrees Celsius for temperature 2. At the 10th minutes, the analysis was carried out in the evening and the weather was sunny. The lowest temperature that has been recorded is 29 degrees Celsius for both temperature sensors. The low temperature was recorded in the 6th minutes 60 minutes due to the dim and not too hot weather condition. This diagram shows This figure shows the result of the data on the on time with the humidity. There is a difference between humidity 1 and humidity 2. The sensor for humidity 1 is at the bottom of the solar panel, so it less exposed to the heat, causing the humidity to be high. Meanwhile, humidity sensor 2 is placed in front of the solar panel, causing it to be more exposed to heat and causing the low humidity. For the conclusion, the development of the PV solar panel with a cooling system represents a significant stride in enhancing the learning experience associated with the solar technology. The finding affirm the practicality and educational value of the PV solar panel with cooling system, positioning it as a valuable resource for understanding and optimizing solar technology application. PV solar panel with a cooling system not only serve as an educational tool but also paves the way for potential advancement, ensuring continuous improvement and innovative in the field of the solar energy generation. This work lays the foundation for the future enhancement that can contribute to the sustainability and efficiency of solar technology in various environmental conditions. That's all. Thank you for hearing.